Hi everyone, welcome back to Revision with me, Mr. Bailey. Hopefully again you're all still staying well, staying safe, and doing your online learning as well, making the most of this time that we have available to us. Hopefully by now you've been practicing everything that we wanted you to do, so really important you keep practicing those spellings, keep practicing your times tables, keep practicing everything that we're giving you basically, because while we're off it's really important that we keep practicing those things, especially things that we find more difficult, to really understand them. So for example, if you've had a video that I've done for you already that you might have found a bit more difficult, please go back and rewatch it 2 or 3 times and keep practicing. If you need to do it once a week, once every couple of days, just to help you with it, then it's better to go back and do that rather than to think, oh, I can't do it and give up. Okay. So today, what we've already done previously is we looked at multiplication, times tables, how we can put those into some long multiplication questions. We're going to look at now factors and common factors. Okay. And then we're going to link this with a task for you to do later, and then that will link again to tomorrow's topic. Okay. So factors and common factors. So what I'd like you to do is just talk to the people around you, might be your parents, carers, guardians, brothers, sisters, aunties, uncles, whoever you're in the house with at the moment. What is a factor, first of all? How do you know what factors are, and how can you find different factors of numbers? Okay. So hopefully by now you've paused the video and you've had a bit of chance to talk about what a factor is. So a factor is any number that can be multiplied to make a bigger number, basically. So I don't think I've explained it very well. So I'm going to give you an example. If we look at number 12, okay? So factors are any number that you can multiply to make 12, to give you the answer of 12, okay? And usually, or not usually, all the time, factors will come in something called a factor pair. So how many ways can I make 12? Well, I can do 1 multiplied by 12. I can do 2 multiplied by 6. And I can do 3 multiplied by 4. Okay? And I like the numbers 12, 24, 16 because it gives you a lot of factors for you to work out. Whenever we're thinking about factors, we need to have a really good secure knowledge of our times tables. And whenever we talk about factors as well, what a lot of people do is they think of the first number and then they miss out loads of numbers in the middle. So I'm going to give you teach you basically a bit of a systematic way of finding all of the factors for a number. So again, I'm going to use 12. I know I've just given you the answers, but I'm going to show you how I would do it. Okay? So with the number 12, I know that every number, with the exception of 1, which is the number 1, has at least 2 factors. We're going to talk about numbers which only have 2 later on, and talk about numbers which have odd, even, these kind of things. Most numbers will have an even number of factors, so the majority of them will. When I'm thinking of number 12, I know that the first number that goes into, that I can multiply, is always going to be 1 multiplied by whatever the number is. So in this instance, it's the number 1 and the number 12. I'm just going to put over here 1 times 12 so that, just so you can see what I'm doing. I know it looks more like an add. I'm standing sideways, so it's a bit more difficult for me to make the right symbol. So 1 and 12, 1 times 12. Okay. Now I look at my number here. Is my number an even number? If my number is even, then I know there is a certain multiplication table that it must be in. So 12, is 12 an even number? Yes. So therefore I know it must be in the 2 times tables. Okay. If it's odd, then it cannot be in the 2 times tables, so I move to the next number. 1 times 12, 2 times what? It'd be 2 multiplied by 6. Okay. So now what I found out is I found that 1 times 12, 2 times 6, these are 4 different factors of 12. 1, 2, 6, and 12. Okay? I know that if I look at this gap here, I have number 1 and number 2. There are no whole numbers in between my numbers 1 and 2, which means that there are not going to be any factors in between 6 and 12. Okay? 7 is not going to be a factor of 12, 8, 9, 10, or 11. None of those numbers can possibly be a factor of 12 because I've got 1 and 2. 1 times 12, 2 times 6. It's going to have to be a decimal. If I multiplied 1.5, it would be 9. 1.5 multiplied by 9, but that is not a factor because it is not a whole number. So they have to be whole numbers, not decimals, not fractions, not anything in between. Okay? Then I look at my next number, 1, 2. 3 is 12 in the 3 times tables. Well, if I'm not quite sure, I know for a fact it is, but if I'm not quite sure, I can count. 3, 6, 9, 12 gives me 3 multiplied by 4. Okay? If I look here, what I'm now going to do is put a line and just call it the halfway point. 1 times 12, 2 times 6, 3 times 4. Okay? Now can you see that I've got two numbers that are next to each other? 3 and 4. If I've got 1, 2 and 3, I know there's not going to be any numbers in between 3 and 4. There's not going to be any numbers in between 4 and 5, because otherwise there'd have to be a number between 12 and 3. I'm happy that I've got all of my factors. Okay? So that is how we work out all of the factors of a number. Okay? There are certain numbers we could have. I'm going to do the same again now, just to show you again, and just to model through my thinking as I'm working out with a bigger number. So I'm going to choose the number. We'll go 18. 18. So I'm going to put it in a circle. So number 18. I know straight away that every single number has at least two factors. They are 1 and the number that I'm multiplying, so itself, 1 and 18. There is not going to be any number bigger than 18 in my list of factors. Is it an even number? 18, is it even, ends in 8? Yes. So 2. I'm going to multiply 2 by 9 to make 18. Again, I know there's not going to be any numbers in between 8 and 18 and 9, sorry, not 8. 9 and 18, and because otherwise it would have to multiply it by a decimal. Number 3, is it in the 3 times tables? 3, 6, 9, 12, 15, 18. Yes, it is. So it is 3 multiplied by 6. Now I'm only left with 4 and 5. The only two numbers it could possibly be. I know it cannot be any number in between 9 and 18. Otherwise I'd have to multiply it in between number between 1 and 2. It cannot be any number in between 6 and 9, so it can't be 7 or 8. Otherwise it'd have to be a number in between 2 and 3. Is it the 4 times tables? 4, 8, 12, 16, 20. No, it's not in the 4s. So it's definitely not 4. The only number that's left in between 3 and 6 is a 5. Is it 5 times tables? 5, 10, 15, 20. No, it's not. So therefore, there are 6 factors of 18. Okay? So your first, I'm going to set you. I'm going to give you a few numbers to find out the all the factors of now, and then I'm going to set you a little bit of investigation afterwards. Okay? So I'm not going to go through the answers, but just give you a little bit of time to practice. I'd like you to find all the factors of 25, 24, and 23. Okay, and what you'll probably find out is that all of the factors are going to have slightly different amounts of factors for each one. I'm going to discuss why in a moment. So pause now and try to work out all the factors of these numbers. Okay, so hopefully by now you've had a chance to work out all of these factors. There are certain numbers that will only have two factors. What I'd like you to do now is try and discuss why the number 23 only had 2 factors. So the only numbers that can go into it are 1 and 23. Discuss why, because there's a word for this, a term that we use for these numbers. Okay, so hopefully by now you've figured out that they're actually prime numbers. So if I were to look at number 7, the only numbers that I can create 7 by multiplying any 2 whole numbers together is 1 times 7. There's not going to be any other numbers in between. It's not in the 2 times tables, the 3s, the 4s, the 5s, or the 6s. Therefore, it has to be a prime number. Okay? So that is your first. So hopefully you found that out already. Your next investigation task, okay? Can you create 3 numbers that have an odd number of factors? Okay, so that's can you find any 3 numbers that have an odd number of factors? As I said earlier, most numbers will give you an even number of factors. There are some special numbers that will give you an even number, an odd number of factors. Can you figure out what they are? So pause the video now, replay when you've got your three. Okay, so hopefully by now you've realised that there are certain numbers that can give you an odd number. You might have worked these out by coincidence. You might have just worked on numbers going up by going 1, 2, well, we'll try 3, we'll try 5, we'll try 7, and we'll try 11, for example. Hopefully by now you've realised that none of these would have worked. If you've actually worked out three numbers, hopefully you've realised now they're all the square numbers. So if I had the number 16, yep, all the numbers that go, so we'll do the same as what we did before. It's the same as 1 times 16, 2 times 8, 3 times tables, no, 4 times tables, 4, 8, 12, 16, yep. But actually, it's the same as 4 multiplied by 4. So what I don't want to do, I don't need to put another 4 in here, because 4 is just one factor, it can't be two factors. So there, the number 16 has 5 factors. So because any number, if it's a square number, for example, 100 is a square number of 10, then 100 will have an odd number of factors. 16 will have an odd number of factors. So if you haven't already found 3 more, now try and work out with your knowledge of square numbers, we're going to move on to this next lesson anyway, can you find 3 more? Off you go. Okay, so hopefully by now you've had a chance to find lots of different numbers that have 5 factors, and hopefully you've realised and made the links with actually, if a number only has 5 factors, then it must be square. If I know that number is a square number, it has to have an odd number of factors. Okay? So this brings us up to our final part of the lesson. So we've done factors, and we give that a tick. Now once we've done our factors, and we know our factors, we understand what factors are, we can find factors of a number. Now what's really important to try to do is try and figure out what numbers have in common. So if I was to put 2 numbers on the board, and I'd like to find the factors, and go through it afterwards, and which factors in both numbers are the same. Okay, so my numbers are going to be 12, I'll choose a big number, 36. So pause the video now. How many numbers can you, so first we'll find all the factors of 12, all the factors of 36, and then we're going to talk about which numbers are common, how we know. Okay, so stop the video now, give that a go. Okay, so hopefully by now you've had the chance to figure out the factors of 12 and 36. What I'm going to do is just going to show you now and say out loud, model my thinking, how I would find the factors of both and then try and figure out which ones are the same. So 12 is the same as 1 times 12. Is it even? Yes, so it's in the 2 times table. 2 times 6. Next number 3, is it in the 3 times table? Yes. 3 times 4. Are there any numbers between 3 and 4? No, so I must have found all of my numbers. Okay. 36, I can do 1 times 36. Is it even? Yes. 2 times, well, if I half 30, it would be 15. Half of 3 would be, half of 6, doing thinking in my head. Half of 6 is 3, add them together, 18, so 2 times 18. This is where people might think that actually, no, it's not, because we only see times tables as up to 12. Actually, if I was to keep counting in 2s, 20, 22, 24, 26, 28, 30, 32, 34, 36, it is in the 2 times table. So just because we don't necessarily stop at 24 like we do when we count, times tables can keep going on. All it is multiples of those numbers. So is it in 2 times tables? Yes. 2 multiplied by 18. Is it in the 3 times tables? Well, yes, it is. It's 3 times 12. Is it in the 4 times tables? Yep, it's 4 multiplied by 9. Is it in the 5s? Well, in order for it to be in the 5 times tables, it has to end in a 5 or a 0. So no, it's not. Is it in the 6 times tables? Well, actually, yes, it is. It's 6 times 6. So now I've got my 6. I know it's not going to be 7 or 8 or a 5. I'm happy I've got all of my numbers. So you can see, first of all, that different numbers have different factors. Bigger numbers do not necessarily mean that they're going to have more factors. However, it is possible. Okay, I can have a large prime number, and I've got 12 here, I could have 17. 17's only have 2 factors, 12 has 5. Just because it's got a big number doesn't mean that there's going to be more factors with that number. So now, what I want to do is highlight the numbers. I'm just going to go around starting from 1 on both, and I'm going to write down all the numbers that are common. So common factors, all the common factors that are in both, so the factors in both common factors. There's 1. It's going to take so long. Next number 2, yep. Next number 3, yep. Next number 4, yep. 6, yep, that's there. Next number 9, there's not a 9 in this one, so that is not a common factor because it is not the same in both of them. Next number 12, yep. 18, no. 36, no. So actually, when we look at the numbers 12 and 36, the common factors are 1, 2, 3, 4, 6, and 12. Actually, I knew that these were going to be the common factors before, because if I multiply 12 by 3, I get 36. So all of these factors here would have to be factors of 36 as well, because I can multiply it together. Okay. What your next challenge is to try to create 2 numbers. Any numbers you want to do, any 2-digit numbers. How many can you find, and what is the highest number of common factors you can find between 2 numbers? Can you beat 6 here? That's your challenge. Tomorrow we're going to be learning about square numbers and cube numbers. Okay, thanks for watching. See you next time.